you can ask any questions if you have them. So quick warm up. You don't need to fill this part in. Just talk me through it. What do you see here? What should we do? Plus a positive. Minus a negative is plus a positive. And then we combine like terms. So 16, but still k squared, right? We don't change the squared. We don't change the k. 16k squared. What about letter B? 4xy plus 9xy.
13xy.
13xy. Add the coefficients. Leave the variables the same. Okay. What about letter C?
It's 12x minus 4.
Right. Combine the like terms. So 9x plus 3x is 12x. The negative 4 is not a like term. Can I subtract this? Are you trying to find this?
No.
No.
Do you have a question?
No,
Yeah.
you just
Were we
leave
supposed
it.
to like turn in our chapter 1 notes?
Oh, yes. There was an assignment that should have popped up for you. Yeah, if you didn't turn in your notes, turn those in. I won't mark you late if you turn them in now. But yeah, if you haven't turned the notes in from chapter 1,
You have to
turn
leave
those
it
in.
because it doesn't have the variable.
Yeah, you cannot combine them because they're not like terms, right? One has the x, one doesn't. Can't combine them. Okay, this one.
2t plus 2.
Right, you're subtracting, okay? It's not this plus, it's 6t minus 4t. So 2t plus 2. It's like you guys learned how to do this already. Good job.
Isn't that crazy?
Yeah.
The whole lesson.
No, that's the warm-up. This is actually stuff you've already learned how to do. This is the lesson.
We finished early last year, so Miss Brennan taught us that.
Taught you,
Like
The-
chapter
chapter 1 stuff?
Yeah, she did.
Gotcha. Well, that's good. Okay, so you are going to do some properties today. And we've talked about some properties, right? Commutative, associative, all of that. These ones are different. These are operational properties. This is like inverses, doing the opposite of what we do to solve an equation. So the two properties we're going to start with are called the addition property of equality and the subtraction property of equality. And here's what they say. If you have a setup, and it's all right here, but I'm going to work it out off to the side so you can see what I'm saying as I write it out. So if I have like x minus 4 equals 7, okay? You can guess and check and plug and chug and try to like come up with the number. Like what would x equal? What minus 4 equals 7? And you can think through it and go, oh yeah, it's 11. But you're going to get to a point where you're using numbers and it's not that simple. So you need to know these properties to be able to solve. So here's what you do. The addition property of equality says you do inverses. You do the opposite operation. So what is the opposite operation of subtraction? It's addition. So the inverse property says if this is a minus 4 and I want to get x by itself, because that's our goal, right? Get x alone. Do you know the word that I'm going to use for that all the time? Isolate, okay? When I say isolate the variable, I'm saying get x alone. So if I want to get x alone, I have to get that 4 out of there. Well, what is negative 4 plus 4? 0. So this goes away. But whatever you do to one side, this is the golden rule of algebra, you have to do to the other side. So x is alone now. 7 plus 4 is 11. So all we're doing is the opposite of the operation we see there. If it was minus 4, we go plus 4. Okay?
Did we have to do that on our test? Like,
No, you didn't know how, well, you maybe know how to do this already, but the one on your test was just like find the number. It was a plug and chug. It was if you wanted to set up a table, you could set up a table. I think it was -3. Does anyone remember? Was the test -3?
I think so.
I think so. Everyone in here took it, right? I don't think there was anyone that missed it. I mean, it was -7. No, it was
It's
-3.
actually positive.
Okay, so that is called the addition property because we are adding, okay? The subtraction property is just the opposite. If I have something like x plus 9 equals 11, let's say, okay? If this is my setup and I want to get x by itself, I have a positive 9 on that side of my equation right now. You get rid of it by taking it away. Make it 0. This is 0, but whatever you do to one side, you have to do to the other. So x equals 2, okay? Do you know how you check your work on these?
Calculator.
You plug it back in, right? I mean, you can plug it in your calculator. 2 plus 9 is 11. We got it right. 11 minus 4 is 7. We got it right, okay? So you can always plug it back in to check your work. Okay, so here are the things I just told you. To solve an equation, you must isolate the variable. Get the variable by itself, and then you use inverse operations to isolate the variable. So what would the inverse operation to addition be? Subtraction, okay? So addition and subtraction are inverse operations. What other two operations are inverses? Multiplication
And squared.
and division. And what?
Squared and squared cube.
Yeah, squared and square root,
Or square root. Yeah.
right? Those are inverses also. Yes, that is true. Okay, so here's what we're gonna do. We are gonna solve these 5 equations by using the inverse. These first ones are subtraction. So you have, excuse me, x plus 13 equals 27. I want x by itself, so I need to get 13 out of there. What do I do?
Minus 13.
Take away 13. That is 0. Take away 13 on the other side, and you bring down your x, you bring down your equal sign. 27 minus 13 is 14. Okay, so if we were to plug that back in, 14 plus 13 is in fact 27. We know we got the right answer. Okay, so what do you do for B? Minus 2. Now, be careful with negatives, please, because negatives are what always seem to cause the problems. That is a negative 6 minus 2. If they're both negative like that, you add them together and keep the sign. So this is a negative 8. Okay. When in doubt, plug it into your calculator. I know it's easy to do mental math, but sometimes the mental math gets done wrong and then everything's wrong. If you're like, I'm not 100% confident, I think it was negative 8, but I'm not sure, plug it into your calculator. Let your calculator tell you that you're right. Okay, take a look at this one. Our variable is on the right side. Does that change what we do in this problem?
No.
Same problem. You could rewrite this if you really wanted to. I wouldn't, because you risk writing something wrong. But you could rewrite this, b minus 3 equals negative 7, okay? What is the inverse operation that we need to do here?
Plus 3.
We need to go plus 3. So you're going to go plus 3 on both sides of your equal sign, right? You should always have something on the right and something on the left. I did that backwards for you, didn't I? So bring down your b. This is 0. B equals negative 7 plus 3? Negative 4. Okay, you do the next two. Try, what? You okay?
I don't know if you're supposed to plus 7 to that side or plus 7 to that side.
Good question. We're trying to get the variable by itself, so you want to move things away from the variable, right? So if we brought the 7 over, this is such a good question. I'm so glad you asked that. Watch this, okay? This is what happens a lot. This is a common mistake. Okay, a lot of times people go like this, plus 7, and they get 4, and then they say b equals 4. But my equal sign is here, not here, right? Because the b is still on that side. So if you are gonna do that, it's not wrong. You can do this. Okay, I can add 7. But now what do I have on this side of my equation?
Nothing.
A 0, right? 0 is a number. Don't just ditch the 0. If it's the only thing on that side, you got to leave it. So this would be a b plus 4. What would you have to do from here?
Minus 4 on each side.
So take 4 away to get, yeah, I wouldn't do it this way. But it's not wrong. Like, you will get there. Negative 4 is your b value. You could do that, okay? Don't move everything to one side of the equal sign. Leave the variable on one side, move everything away from the variable to the other side.
What if there's variables on both sides?
We'll get there. Yep, that's coming in like 2 or 3 lessons. So I'm not even gonna go there yet because I don't wanna start confusing people. We're just gonna stick to what we're doing here. So do letter B and letter C, and then see what you come up with. All right, so tell me what you did for B. You added 8. Okay, so add 8 to both sides. And again, watch out for those negatives. M equals what?
6,
Negative 6. Negative 14 plus 8 is a negative 6. And you can always plug it back in to check your work. What'd you get for C?
+3.
You would add 3 halves, right? Add 3 halves. So this is 3 halves plus 1 half, and you're left with just the y on the right side right now. What is 3 halves plus 1 half?
2.
It's 4 halves, which when simplified is 2. Katie, I think this is what you were talking about. Is it okay to write it like that? You can absolutely write it like that. If you like it better like this, you may turn it around too. But 2 equals y is the same as y equals 2. Good on that? Okay, then our other inverse operations are multiplication and division. And this, I would say multiplication tends to be the one that people do wrong the most. So if you checked out, check back in. Let's say we have x over 2 equals 8. Okay, this setup right now is saying x divided by 2 equals something. I want x by itself. So I want to get rid of that 2 that I'm dividing by. What is the inverse operation to division?
2 times 8.
Multiplication, right? We're going to go 2 times 8. Because if I multiply by 2 right here, 2, this is essentially 2 times a half. That is 1, right? That becomes the number 1. But whatever you do to the left side, you have to do to the right side. So x equals 16. Okay, now go back and plug it back in. 16 divided by 2 is in fact 8, so we know we got the right answer. Okay, so if you are doing division, do the opposite and multiply. Division property says if you are currently doing multiplication, so something like this, 5 times x equals 25. This is implied multiplication, right? When you put a number next to a variable, they're basically saying, put a dot there. We are multiplying. You don't have to put the dot there, but that's what's happening, okay? So the opposite of multiplication is division. What is 5 divided by 5? 1. So this goes away. Now we have 1x. I don't need you to write the 1. It doesn't matter, but you could if you want. So x equals, whatever you do to one side, do it to the other side. X is 5. Questions on that? Okay, so those are the other 2 properties that we're going to use. We have 4 of these, and then I have one last thing to show you with fractions. So letter A, 4x equals 6.4. What are we doing here? We have to divide by 4. Right now it's multiplication. We do the opposite. So whatever you do on one side, do it on the other. You're going to want your calculator on that. 6.4 divided by 4 is 1.6. Oh, come on. 2.2? 1.6. Did I do it wrong? 1.6. Yes, ma'am.
When you're dividing like the next one, when it's negative 3.2, would you turn it into a positive 3.2 or would you?
No, that's a great question. If you're dividing, if I want to get rid of a negative 3.2 and I'm going to divide by 3.2, what is negative 3.2 divided by 3.2?
Positive. Wait, what?
A negative divided by a positive is a negative, right? So don't ditch the negative. You want to get rid of the negative. A negative divided by a negative is a positive. So you want to divide by the negative if that number is negative. So divide by negative 3.2. This is 1. So z equals 14 divided by negative 3.2 is negative 4.375. And put boxes around your answers or circles or highlight them. Just some way that I know, here's my answer. On the homework, I don't care as much because you're checking your homework. But on a quiz or a test, if you are one that doesn't work super linear and you have work all over the place, I can't always tell where you ended. Like, what's your final answer? I don't know. So put a box around it, put a circle around it, highlight it, whatever that looks like. Questions on this? Okay, here are the ones that I think get done wrong the most. Well, this and the next one. This problem says x divided by 4 equals -9. So what is your inverse operation? Multiplication. So we're going to multiply by what on both sides? By 4. Because 4 over 4, we say that 1's out, right? 4 over 4, we don't cancel it. It's not getting canceled out. It is a number still. It's the number 1, okay? So that 1's out. We multiply by 4 over here, and x equals what? -36. Okay. All right, so what do we do on letter B? Multiply by 3 on both sides. This one's out. 19 times 3 is 57. So R is 57. And if you're not sure, plug it back in and check it. 57 divided by 3 should equal 19. Questions on that? Okay, this one's a little bit goofy. What operation is happening right now between the 4/5 and the M? Multiplication. So the inverse operation would be what?
5 over 4.
Division, right? Is the inverse operation to multiplication. However, when you divide fractions, you flip and multiply, right? So if you want to write it out like that, where you show me all that stuff, you are totally welcome to do it. I don't recommend it. It's a lot of numbers and flipping and something gets done wrong. Instead, when it's a fraction times a variable, you can multiply by what some of you just told me, multiply by the reciprocal, because 5 over 5, 1's out, and 4 over 4, 1's out. So all I'm left with on that side is M. But if I'm going to do it to one side, then I have to do it to the other side too. Okay, now here's where personal preference is going to come into play a little bit for you. Are you the type of person, and this is just a question for you, it doesn't have to be what everyone else thinks. Are you the type of person that is going to see this as 28 over 1 times 5 over 4, multiply straight across? So 28 times 5 is, 28 times 5 is 140 over 4, and then reduce that. 140 over 4 is 35. Okay, that's one way you could do it. Or are you the type of person that wants to cross reduce first? Do you remember doing cross reducing? 28 and 4 are both divisible by 4. So you could make this 1 and 7, and then what do you do?
7 times 5.
Multiply across. 7 times 5 is 35. I don't care which one you do. I am curious which one you prefer because I will try to do the one that is most preferred by the class as much as I can. But I'll try to mix it up some just so that if you like the other way, you see it the other way sometimes. So out of curiosity, how many of you think I will just multiply across and then reduce at the end? Okay, how many of you think I will cross reduce like this and then multiply across? Okay, so it looks like we're pretty heavy on this one. So I'll try to do that one more often, but if you ever want to see it the other way, those of you that just raised your hand, just tell me and I'll do it that way too, okay? Okay, so either way, M comes out to 35 and that's your answer. And then if you wanted to, plug into your calculator, 4/5 times 35 and you should get 28. All right, you do letter B and then we're done. Give that a go.
What time does stop sign?
All right, tell me what you did. Yeah, Shane.
multiply the fraction, and then.
By what?
By the same thing.
2/3?
Yeah, 2/3.
Don't do that. Because 2/3 times 2/3 is 4/6. So now you have 4/6x on that side, right? Make sure you take the reciprocal. If you're going to multiply by that fraction, you got to take the reciprocal. So times 3/2, and then do that to both sides, right? Times 3/2. So 3/3 is 1, 2/2 is 1. So you have x on the right. What does this become? 36/2. If you multiply across, right? 12 times 3 is 36/2. And 36/2 is 18. Questions on that? What did you do?
I did 12 divided by parentheses 2/3.
Right. On your calculator. Yeah. See, like mathematically, if you didn't have a calculator, that isn't going to calculate very well. It is true, right? And you get the right answer. But the process that I want to, like, if you're going to show me your work, which you always have to show me your work, you should multiply by the reciprocal, because that's what division is, right? If I have 12 divided by 2/3, that's the same as 12 times 3/2, right? When dividing fractions, don't be shy, flip the second guy and multiply instead. So yeah, multiply by the reciprocal. Okay? Questions on that?